And welcome back. As we get ready to now look at the other side of dealing with text files, last time we talked about reading in data from text files, but now we're going to look at being able to write data to a text file. So the way we're going to do this is with the PrintWriter class. The PrintWriter class is the preferred stream class for writing to a text file. There's actually a couple different approaches that you can use to write to a text file, but this is the one we're going to look at today. Now, an object of the class PrintWriter has the methods print and println, which are very much like the methods system.out.print and system.out.println that we use for screen output. However, with an object of the class PrintWriter, the output is going to a text file instead of to the console. So to create an object of the class PrintWriter, we can use PrintWriter output stream equals null. And it's outside of a try block, which is again very similar to what we saw last time with our scanner. And then we see output stream is equal to new PrintWriter new file output stream stuff.txt. All right, it'll just be whatever. Of course, this can be replaced. We could call it sample, we call it numbers, whatever it's going to be. Now, when we actually get into working with this, we have to first off by opening the file. All right, much like how when we write to the file, we have to use a try catch block. The variable output stream is of course of type PrintWriter and is declared outside the try block. Then inside the try block, we connect that output stream to our file. In this case, it was called stuff.txt, but again, that doesn't have to be the name. It can be whatever text file we want to connect that to. Now, when we connect a file to a stream this way, the program is always going to start with an empty file. So if the file stuff.txt actually exists, anything that was in there is going to be lost. It's going to delete it, it's going to purge it, it's going to be bye forever. If the stuff.txt does not exist, then it's going to create a new empty file and then be able to write data to it from there. Now, when we talk about the file output stream, we have to associate with the file. All right, that's the key thing here of how this ends up working. So what happens is the class PrintWriter, if you actually look at it, it doesn't have a constructor to take in a file name. So we have to use file output stream, which is very similar to last time we had a file input stream. All right, and that's going to be our argument to the PrintWriter constructor. Now, the expression file input stream stuff.txt is the argument we're passing in, and it creates what's known as an anonymous object of the class, which is then used as an argument for that constructor. So new PrintWriter new file output stream stuff.txt. Don't worry about what an anonymous object is at this point. Just know that's a terminology that we're going to see and kind of get familiar with. But at this point, you don't have to have full understanding of what it is. Just know that this is the format that we're going to end up using whenever we want to use a file output stream. And then, of course, we have to read in the file name. So if we look at the name of our file, stuff.txt, this is given as a string, and so we put it in quotes. If we want to read the file name from a keyboard, you could, of course, give it to a variable and then pass that in. For example, string file name equals kb.nextline, output string is new PrintWriter, file input stream stuff.txt. And so we can, of course, replace, for example, stuff.txt with file name. Now, just like when we had our input stream, where we had the scanner class and we're reading in from a text file, because we're dealing with files, we have to have a file not found exception. And that's why we have our catch block. And so anytime we try to open up that file, because it has to open it in order to write to it, we need to have that file not found exception on standby. The only place an exception might be thrown is in our try block when it tries to open up the file. Also note that the variable output stream is again declared outside the try block. This is so that that variable can be used outside. So if we try to use, for example, just like when we had scanner file in, if we try to do that here and we say, hey, we don't have it outside the try block, it's not going to know what to do with it. It's going to give us a bunch of errors. Anything declared in a block, even a try block, is local to the block. It only exists within those set of curly brackets. Now, when we look at file names, for example, we have stuff.txt. That's just one example name. We can technically name that file anything that we want when we're writing out to that file. Because, again, we're choosing what to name it. However, we do still have to follow the rules of whatever operating system we're using. All right, this is not dictated by Java. It's dictated by your programming language of your operating system. So that when the operating system says, hey, I don't allow these certain characters to be in my file name, you can't use it. So when you give a file name for Java, you're not giving it a constructor as a Java identifier. You're giving the constructor to say, hey, this is a string that's going to become the file name. The suffix, such as .txt, Java doesn't care what that is. All right. Instead, that's going to be for your operating system, for your computer to look at and say, aha, it's a text file. Of course, we're using TXTs for text files because that's a pretty common extension here. You can, of course, write this to other text or other types of files, but of course, you might have different encoding and stuff like that you might have to handle. One of the reasons why we deal with text files is because we don't have any other special rules that we have to kind of adhere to. And as I mentioned, we only use file names that are allowed by the operating system itself. Now, obviously, when we're done with the file, we have to make sure we close it. Closing the file is going to be very important, just like when we saw with our input streams. Output streams are going to be the same way. So when our program is finished writing to the file, it should close the stream that's connected to it, which of course we just use output stream.close. The class PrintWriter and any other class that's for file or file input streams has a method named close. When this method is invoked, the system releases any resources used to connect it to the file and does any housekeeping it needs to do to kind of clean things up behind the scene. Now, of course, if we terminate our program before the closing happens, Java will automatically close that for us, so you don't have to worry about just hanging out there on your computer. However, it is safest to close that file with an explicit call because this helps prevent data integrity and corruption and stuff like that from messing things up. Now, as I just mentioned, why do we use close? All right, and give a little bit more idea of with that data integrity and preventing corruption. Like you can say, like, well, I can just close it. It's not going to hurt anything, right? It's just a text file. Well, the program will end normally if you don't use .close, but the system, even though I'll make close for you, that explicit call is there for a reason. All right, if we were for some reason we just close it normally, which is like just let Java close it out, we could run into some issues. Like I said, we could damage the file. If it is an output file, which is what we're currently going to be doing, any buffered output, which means output that's currently stored in memory, may not have been actually written to the file, and so your file would then be incomplete. So the sooner we close that file, the less likely is we're going to lose something. Secondly, if our program writes to a file and later reads from that same file, it must close the file after it is done writing to it and then reopen it to read it. So you can't both write and read from the file until you have closed one of those streams. So if we were to, for example, we were to take our program we're going to do today, we're going to go ahead and write to it with an output stream, and then we try to read it, and we didn't use .close, it's not going to let us do that. So we have to make sure we always use .close here. And here we are, of course, looking at some code. You can see this is a pretty simple example here. So I'm going to go ahead and have my 3 import things. You'll see this is a little different than what we've seen before. There's no scanner class here. Instead, we have PrintWriter, which of course is what actually let us go to that text file. We have our file output stream instead of our file input stream that we looked at last time. And of course, again, file.foundException. So we create our PrintWriter output stream. We set that equal to null. So just like how with our scanner file in, we of course are doing the same thing here. And then we say output stream is equal to a new PrintWriter. And that, of course, is just writing to whatever you want to name this. Now, this is just stuff.txt. I could call this something else. I could call it sample. I could call it numbers, whatever I want it to be. Again, this is just the name of the file. This is our catch in case it can't open it. And all I'm going to do is I'm going to get a prompt that says write to the file. And then I use these output stream.print lines. And you'll see all this is going to do is write this to the file. It's going to say writing this sentence file. This is also written file. And of course, we have this new line character in here. And then we have printing a number is the same thing as a string because you'll see we also do a numeric input. So we, of course, can just print out a number because to the text file, it doesn't matter if it's an integer or not. Like, yes, we can technically do a printing of an int. However, when we're going to a text file, with a text file, it doesn't care if it's an integer or not because it's going to store everything as a string anyways. And then, of course, we close out our stream. Now, if I go ahead and run this, and notice there is no text file currently here in my hierarchy. So I'm going to go ahead and run this program. And you see that we get the message writing a file and a program. Excellent. And if I go over here to my 2.8, I'm just going to go ahead and refresh this. You'll see I now have stuff.txt up here right here. And then when I open up stuff.txt, you'll see there is this stuff that I wanted to write. So you see write the sentence to file. This is also written to file, but on a new line because it does also still process escape characters here. And then of course we had our variable here. Here I went ahead and printed out a variable. Now I could have put 100 explicitly in here, but I did this with a variable just to show you that you can still do variable output. And you can see it puts it here as 100.